Today we're going to talk about graphs of logarithms. How do exponential functions compare to logarithmic functions? In the logarithm video before, I mentioned that exponential functions have inverse functions, which are logarithmic functions. Since exponential functions and logarithmic functions are inverses of each other, the graph of the logarithmic function is the reflection about the line y equals x of the graph of the exponential function. So we have graphed in blue the exponential function where a is greater than 1. And so what happens is when we want a logarithmic function from an exponential function, we take the inverse. And so basically we have this line y equals x, and our graph gets reflected over this line y equals x. So we get new points. Our points that we currently have will be switched from x and y. So we're starting down here at negative 1 comma 1 over a is going to change into negative, we're going to have 1 over a comma negative 1. And then 0 comma 1 is going to change into 1 comma 0. And 1 comma a is going to change into a comma 1. And this is going to be our new graph, and this is going to be our graph of y equals log base a of x. And that's how exponential functions compare to logarithmic functions in graph form. So now let's do an example. We're going to graph y equals log base 2 of x. We're going to do this by using our points. So I've created a little table here. We got x equals 1/4, 1/2, 1, 2, and 4. I chose these numbers because I rewrote this into exponential form, which is x equals 2 to the y. So I need x values that 2 to something will give me. So we plug in 1/4 and we get log base 2 of 1/4 is negative 2. Log base 2 of 1/2 is negative 1. Log base 2 of 1 is 0. Log base 2 of 2 is 1, and log base 2 of 4 is 2. And now we're going to plot our points. So we're going to have 1/4, negative 2 is probably about right there. 1/2, negative 1 is right there. 1, 0, 2, so we're going to have 1, 2, 1 right here, and 4, 2 all the way over here. And then we connect the dots to make our graph. It's going to keep growing exponentially, so it's going to keep going up, and it's going to come down towards the y-axis, but never touch the y-axis. And so this is the graph of y equals log base 2 of x. This graph leads us to properties of y equals log base a of x. So first property is the domain, which the domain is the set of all positive real numbers, so it's from 0 to infinity. The range is the set of all real numbers, so it goes from negative infinity to infinity. We can see that from our graph. Number 2, the x-intercept for this graph is it crosses at 1. The y-intercept, there is none because it never reaches the y-axis. Number 3, the vertical asymptote. The y-axis, which is y-axis, which is y, it's x equals 0. Sorry. X equals 0 is our vertical asymptote. 4, the logarithmic function is decreasing when a is between 0 and 1, and increasing when a is greater than 1. So it's always increasing for our graph on the right because 2 is greater than 1. 5, the graph of a contains the points 1, 0, and a, 1, and 1 over a, negative 1. And we saw that in the graph we had before. And then finally, 6, the graph is smooth and continuous. Lastly, I want to compare this graph to the graph of the exponential function y equals 2 to the x that we graphed before in the exponential function video. And here it is on the left. We can see that it is the inverse because it's reflected over y equals x.